Hello and welcome. This is DuPont Presents The Power of Shunya, Challenge for Zero. I'm Gaurav Kapoor and we have two teams who are going to be competing here today to try and get to that grand finale. And why do they do that? Well, they do that to win. What do they win? A cash prize of rupees 10 lakhs and that money can't buy experience, an all-expense paid trip to the DuPont headquarters in the United States. And who's going to decide if they get that or not? Well, it's going to be our judges. We've got the finest minds from science and management to quiz these young innovators and to decide whether they're good enough or not. Let's meet our judges, shall we? Our first judge is the Regional Technology Director of Asia Pacific DuPont, Dr. Homi Vidwar. Hi, Homi, how are you?
I am very well.
Thank you, Homi, for being here, of course, and also would like to thank the CMD of Karma Venture Services, Ms. Nandini Vaidyanathan. Nandini, how are you?
Good.
Our third judge is Mr. Rajiv Karwal. Hi, Rajiv, how are you?
I'm fine. What about you?
Very well, thank you. We have our first team of innovators who are here. Let's see how complicated their thought is and how simple the execution is. Let's call them out first. We have from the Indian Institute of Technology, Kanpur, Ramchander Chepyala, and from the ISB, Hyderabad, Arjun Chaturvedi. How are you, gentlemen?
Fine.
What they're talking about in itself is a complicated tongue twister. Your innovation is called?
Vrana Vani.
Vrana Vani. Now, while we show you this video, I want you to say that real quick 5 times. Have a look at this.
Every year, nearly 6 to 7 lakh people are killed just because of lack of early diagnosis in the cancer. And every year, nearly 1 million cases have been registered in the country. So, there is an urgent need of devices, otherwise immunosensors, which can detect these devices in the early stages so that we can save many lives. Microfluidic is the handling the samples which are in small quantities, and immunosensor is the device which can use these antibodies to detect the diseases. It has the qualities of portability, low cost and easy to handle, and it does not require any technical expertise to handle this device. In our microfluidic sensor, we have a flow station and a microchannel station, that's called a microreactor station. The other one is the electrolyte insulated semiconductor station, where actual sensing is happening. We will be heating the microchannel up to particular temperature. Because these bioreactions are very sensitive to temperature, then in the microchannel, we have come up with a different molecular stacks that we will do at the laboratory scale, and at the end, we will keep the antibodies which are specific to one particular cancer. So from that, we will calculate what is the sensitivity of that device, and from that reading, we can also able to quantify the number of disease molecules present in the serum. After that, this information will be displayed on a digital display. The first people who are going to get benefited from this innovation are common people. We dream that one day there should be affordable healthcare to all the people, and there should be early diagnosis of the diseases. We are reaching to power of Shunya by stopping these unnatural deaths.
Arjun, you're staring at me like you're going to bring out your arrow right now. Don't do it, brother. Don't do it. Yeah? You have 90 seconds, of course. You have to train your arrows towards the judges, right? The bullseye is right here in their mind and one in their heart as well. I hope you can hit both targets. 90 seconds is what you get to tell us your business plan about this innovation. Are you ready? All right, Arjun, your 90 seconds start now.
As per the latest estimates of World Health Organization, in 2012, the number of cancer cases, new cases reported were 14 million, and the number of cases, cancer cases, deaths were 8 million. The respective number for India was 1 million and 0.7 million. Our product, basically in consonance with the Power of Shunya project, aims to reduce the number to 0. How we want to do this? The value proposition of a product basically is, it is a multi-analyte detection. It's on-site detection within a very short span of time. It has a higher sensitivity. It is easy to use, easy to maintain, plus at a very low price. That is at around 25 to 40% price as compared to the competing products. We plan to manufacture it, employ an in-house dedicated sales force to increase awareness and interest in this product. Our target segment, we are targeting this product across all segments, including hospitals, diagnostic chains, and private clinics, so as to, our hope is to finally trickle down the benefit to the final customer and reduce the price of the final test to around 25 to 30%, which will in turn increase the end market itself and reduce the incidence of cancer and the number of cancer deaths to zero.
Well, it's now time for our judges to take over. There's, of course, Ram and Arjun this side, a lot of mythological power. Yes, but does their innovation have any? I'm going to leave that to you to decide.
So what I'm trying to do here is distinguish between what you have as your innovation and what is already out there in the market. So I'm going to kind of say a few key words. One would be lab on a chip. Is that, would your device
Is lab on chip device.
It would be a lab on a chip. It incorporates microfluidics, right? It uses the ELISA assay to do the work, right? So these things are known out there today. So tell me how your device is different and what are the attributes, either in terms of speed or the kind of detection you do and so on.
So the present instruments which are available in the market, those are based on the optical based detections. Usually like fluorescence and chemiluminescence are the techniques which have been used. And in this case we are using the electrolyte insulator semiconductor technology, which is electrochemical based technology. So which is purely based on the measurement of the capacitance versus voltage which is coming out of the sensor. That itself shows the sensitivity of the device, and we can from there we can calculate the...
Yeah, so it's a different technique. It's an electrochemical technique. How does that provide you an advantage?
Using electrochemical technique, we can miniaturize the devices. At present, the sensor which we are using is 1 centimeter by 1 centimeter area, and only the sensing area is 4 mm. So we need nearly around 12 to 15 microliters of liquid to put on the sensor so that it can give you the electrical signal. And since the semiconductor fabrication industry is well established, these are silicon based sensors. Given the sensors to the semiconductor fabrication, the price of these sensors can be reduced, and we can use it for multi-analyte detection. That means...
So let me summarize then. It's portable. It can be used with different analytes, so you can do... It can detect pretty low quantities, right? And how about speed?
At present, if you use typical ELISA technique which are present in the diagnostics, the actual time, reaction time will take nearly 17.7 hours. That's the calculated time. So using this microfluidic immunosensor, we can reduce that time to nearly half an hour, because all we want...
Half an hour?
Half an hour, 30 minutes.
Okay, thanks.
Arjun, what's the plan to take the product to market?
The go-to-market strategy is basically, because this is an innovative product, so the only two options available were either we manufacture the product ourselves or we take the product to a company and sell the product to them. But because of the vision of the innovator itself, the aim of the innovator is to make the effect, the trickle-down effect, reach the customer. So we have to sell it at a price which benefits the buyer, that is the diagnostician lab and the hospital, and thus in turn benefit the customer.
But is the product market ready?
No, it is right now in a prototype stage.
What stage would it be at? Give me a date when it would be market ready.
I believe the answer to that question was around a year.
This is very difficult to answer, ma'am, because at present majority of the knowledge generation part has been over based on my thesis and other students' thesis. So right now we are building the prototype. The project sponsored by DST, SERB. By 2016, we have to demonstrate the prototype to...
So it seems a little premature to discuss this at this stage, right? So I think you're a bit early for a platform like this.
I have a sense that it'll never come to market, you know, because I think it's going to keep going on and on from what I'm hearing.
Make sure that
from what I'm
doesn't
hearing.
happen.
So, go ahead.
I have two small questions. What kinds of cancer can it detect?
Sir, at present in our lab we have focused on the prostate cancer detection, because the prostate specific antigen is commonly available in the humans. That's why we have focused on that. But as I said, if we change the surface chemistry inside the microchannel, keep the specific antibodies over there, and
we can detect any other disease.
And have you although formal clinical trials are to begin, but have you tested it on humans in any way and got some initial results? Or are these just hypotheses which
No,
you're talking
integrated
about?
prototype we have not tested, but individual components were tested. So based on the results, based on the publications we have done and patents we have done, we have come up with this product.
I'm now going to let our judges mark our first team of innovators. 5 parameters they're marking them on: disruption, relevance, reach and commercial viability of the product, the use of science in its development, and of course the Shunya proposition. Rajiv, it looks like we have a score ready from you. Would you like to share that with us, please?
Yeah, basically it's too early, in the journey of this innovation. So as a result, some of the scores, if you had participated maybe 2 years later, it would have been different. But overall, you have got a 48 out of 100 from me.
Okay, thank you, Rajiv. Homi, would you like to share your scores with us, please?
Yeah. The Shunya quotient could be high if indeed this would work, right? So it would be a very good thing. However, I agree with Rajiv that, it is too early right now. My score is 52.
I actually don't know how to mark you because you're not market ready. You don't seem to be interested in building a business and making it commercially viable. So the sense I have is that it's a bit of a, whatever I give you does not correspond to the situation. But I have marked you and my total is 44.
Okay, well, let's give them a round of applause anyway.
Sorry, one question. Vrana Vani, what does it mean?
In Sanskrit, Vrana means cancer, Vani means information.
Disease, the voice of disease. Yeah.
Well, listen, that was our first team of innovators. We have a second team who's going to come and try and break that that leaderboard, so to speak. 240 and 228 are the two scores. We have two teams that have got them, so it is possible. We're going to meet that second team right after this short break. Stay tuned to DuPont Presents The Power of Shunya, the challenge for zero. Hello and welcome back. You're watching DuPont Presents The Power of Shunya, the challenge for zero. 16 teams of innovators, 2 of them trying to get to that grand finale. We've had one team in today's episode. It's now time for our second team to come out and present. So let's just welcome them. From the Eswari Engineering College, Chennai, Sivagurunathapandian Murugan, and from ISB Mohali, Aditya Balani. Hello, gentlemen. How are you?
Good.
Fine.
Okay, first question is, should we call you Shiv, Guru, Pan, Muru, Gun? What should we call you?
Shiva.
Shiva?
Yeah.
Shiva's it's a solid name. I like how that big name just comes into one small, powerful Shiva. And Aditya?
Yep.
Should we just call you Aditya?
That's fine.
Should we, Addy?
That's okay.
Should we also call you Shiva? Vishnu?
Shiva's Aditya.
Shiva's Aditya. They're on the wrong show, obviously. That's the innovation you're talking about. We've heard that story before. We have. Well, that's not what they're talking about, but what they are talking about is this.
We have decided to work in a project where it should be useful for the society and to our country actually. For this, we have approached for Kalpakam. So they have said that these are the problems which they face over there, and we have given the solution for that. Actually, what is the problem is like each and every person who is working inside the field will be facing some communication problem, like it is a secure environment where they are working in. So they want a wireless communication which cannot be tapped. my project is based on wireless communication with security and the monitoring system in it, in a safety helmet. A person who is working in a field is using my device is going to communicate to a person who is in the remote area. The frequency from that wireless device will be transferred through the tower. So in the tower we have programmed it like each and every minute the frequency will be changing. So acknowledgement signal from the wireless communication device will be sent to the tower and after to the person who is in the remote area, and after 1 minute the base unit will change the frequency. So each and every minute the frequency will be changed. So this is the unique thing which we have done as innovation, so it cannot be tapped while the person is communicated to the person who is in the remote area. We have fixed a camera in front of the safety helmet, so person who is going inside the field can work and the person working can be seen by the control room. So they can pass the information from the control room that where the person has to be go. Right now we have developed a prototype model and we have developing features for this, and we have going on adding some features, but if we have a financial support and a proper R&D type of environment means we can develop this product where the world can use it.
Well, our judges will of course question you about the science of it and the feasibility, but Aditya, it's your turn now. You have 90 seconds to give us a little pitch on this product and how you see it going to market and what the future is. Are you ready? Okay, buddy, here are your 90 seconds.
Necessity is the mother of all inventions, and so is the case with our invention. The necessity arose from these nuclear scientists who came up to us and said that they're looking for a secure system. They want to make the entire nuclear plant feel secure. And this is exactly what WiMAT does. Moving on to the core, the customer segment. Right at the core of the customer segment lie these nuclear power plants. But because our product is customizable, that is, we can have various versions of the product depending upon what are the features the particular industry is looking at. Because of which we can take this product not just to the nuclear power plants, but we can take it to the thermal power plants, we can take it to the defense sector, and we can even take it to the mining sector. This will help us in expanding the customer segment way too much. And if you think the diffusion of the product is going to stop here, then the answer to that is no. Because we plan to integrate the technology of this product into something which is as small as a wristwatch. And even in this case, we can have multiple versions of that wristwatch. We plan to come up with the cheapest version, which will have two features which are addressing to the basic need of the Indian society, that is women's safety. We'll have the NFID feature, which will make all the access cards in an organization redundant, and at the same time, we'll install something which is called as a safety button, which will make sure that any time that button is pressed, n number of people in the organization are communicated about the coordinates of that person who is unsecure. So this product basically not only makes each and every worker in a power plant secure, it also makes each and every woman in our country secure.
Wow, tall claims or not, our judges will decide. Homi, would you like to start?
So tell me a little bit about this communication device and why is it secure and what is so novel about it?
Okay, basically like a person who's using the WiMAT, which is a product, like it will send an acknowledgement signal from a device from the safety helmet to the base unit, so that we have programmed a device called as wireless intercommunication networking device, where it will change the frequency at every minute. Like at the 55th second, it will fix a it will be having a frequency previously they are using, and at the 60th second, it will disconnect the frequency, previous frequency, and it will gives a new frequency to communicate with each and every person who is using the safety helmet. So this makes to differ that how the wireless it cannot be tapped.
So you know, frequency changing I think is also pretty well known, right? So help me understand exactly what this novelty part is. What is unique about this?
Actually, in industries like nuclear power plants, there will be many secured information has been passed through the communication. So they want the product like this thing. So they should not be getting the informations go out of the industries. So we have designed it for making the secure thing very secure.
Okay, I understand.
My confusion is, and I think this question probably is more to Aditya than to you. Communication has to be fed to a central monitoring station, right? There is a control room to which the communication has to be fed. If you talk of nuclear plants or any industry for that matter, CMS is set up not by the company, but by the agency to which security is outsourced. So essentially, I'm seeing your product as something that where you can sell it to the security agency. Now in India, security agencies are not so upscale technologically. Wouldn't that be a challenge? How would you break this challenge and convince them that this is something that makes their job easier, helps them perform better, and helps them deliver, productive results? How would you do that?
So I think there are multiple stakeholders that are going to be responsible for making the decision whether they want to actually accept this technology or not. So I mean, obviously the company is going to outsource this to the agency, but if we want to bring out something which is as huge as this product is, we also need to take into account the stakeholder, which is the company, and we need to bring them on the same board. And once we are able to convince them, then it will probably be much more easier to convince the agency.
So the company will in turn insist that the agency adopt your product.
Exactly, probably because our incentives are very much aligned with the incentives of the company. Because our incentives are aligned, we can go to the, we can talk to the agency and basically bring out much better results.
All right.
See, I'm basically struggling in terms of understanding the full scope of what you're trying to do. Because if it is a camera, then the nuclear installation itself, with CCTVs and multiple cameras, is secure from that perspective. If you're talking of security and frequency changing, then the software and the IT firewalls can do that job, which is much better than this one in case there is some information which is being passed out of the nuclear power plant. And if it is that some mishap has occurred in a nuclear power plant, then probably rather than sending humans, robots can do a much better job, like it recently happened when tsunami occurred and in Japan those nuclear power plants got flooded. So, I'm really struggling to fully understand unless you can add some new light to what you have said so far.
If you want to understand the value of 1 second, you ask the person who faced an accident. In this case, if you have to pick up that thing, if maybe a walkie-talkie and talk, you're wasting approximately 2 seconds, right? Here you're wearing that helmet. Your hands are absolutely free. So essentially,
you can also do a joint one apart from the control room with the nearest police station?
Yeah, yes, we can add the features inside the
how much does this whole contraption cost?
For doing this prototype model, it costs around 15,000.
But obviously when we start scaling it up, we can start reducing that cost. And obviously, if we are reducing the features, as I said, in case of a wristwatch, if we are just having the safety button and an NFID, we can bring down that cost easily to less than 1,000 rupees.
We're going to let our judges quickly score and then tell us how Shiva and Shiva's Aditya have fared. Rajiv, could you start, please?
You see, I have given them 48 out of 100, and the highest you've got is on the use of science and relevance. Others are all low, so you have some journey to travel.
Mine was 52, and the high scores were on relevance and the Shunya quotient.
I know something about your product. I know something about the industry you're talking about. And I've known your industry for quite some time, security and safety. I was part of the team that designed the communication protocol for what is commonly known as MI6. So have some understanding of what you're talking about. And I have marked you a little generously, not for where your product is currently or your understanding of the market currently, but I have a fair understanding of the potential of your market. Okay, so it's largely in that framework that I have marked you. So amongst the three, I think I've given you the highest, which is 64.
Well, let's give them a round of applause. Yeah. We could just request Nandini to come out and give the prizes. 164 points, so you are the winners of today's episode. So Shiva, Aditya, if you could just come out here. You both get a tablet device each as winners of today's episode. Congratulations. Congratulations. So 2 more innovations that we saw in today's episode. We still have some way to go before we decide who the top 2 are on our leaderboard. They are the ones who will go into the grand finale. But right now, it's time for us to make like James Bond and disappear. We're going to see you next week on another episode of DuPont Presents The Power of Shunya, Challenge for Zero. Thank you for watching. Bye.